Okay, here's our video on data variability part 2. So we already went over how to make a box plot or a box and whisker plot. So here's two box and whisker plots. And here when we see two of them, we want to check for variability. We want to compare them. So we'll just make the red box A and this other box will just say B. So let's just review to make sure we know the different parts of it. We can see in A we have a minimum here. I'll just say the minimum. We have it as 7, and the minimum on B is 11. And then we have what we call the lower quartile. If you remember, that was Q1. And the median is Q2. And then we have the upper quartile, Q3. And the maximum there. And again, we have, for B, we have the maximum there, Q1, Q2, and Q3. So when we want to compare the two, we can look at the IQR. And if you remember, IQR was the interquartile range. All the IQR was, I'll bring it up here, is Q3 minus Q1. And we want to see if there's any overlapping here. Now you can look at the picture and you can see that there's some overlapping. But let's check. Let's check the red one. So for the red one, I should use a red pen. Right? For the red one, we have Q3 is 14. So we're going to have 14 minus Q1, which is 10. So the IQR for the red is 4. Now for the black, B, we have the Q3 was 18. And Q1 is 16. So the IQR, the interquartile range for B, or the black one, was 2. So you can see there's much more variability in A. That's what the IQR will tell you. So for the B, they're closer. The variabilities are closer. But you can notice something on B. The minimum is far away from the rest of the data. So when you see that, when you see information that's far away from the rest of the data, it's called an outlier. An outlier. Again, it's really not following the pattern. Everything seems to be clustered over here for B, and then you have this outlier far away. Let me give you another example of an outlier. Let's say you had the weights of certain animals, and you had someone who was 10 pounds, and 11, and another 11, or 12, 13. They're pretty much clustered together. Then you have one that's 33. So that one is not following the normal pattern. That's an outlier, the 33. Okay, so let's look at these two, A and B, and see if you can tell me the IQR and label the different parts. So you should pause the tape here and label that and find the IQR of both and see which one has more variability. Okay, so if we label these, this is the minimum, that's the maximum. Then we have the lower quartile, Q1, Q2 is the median, Q3 is the upper quartile, Q1, Q2, Q3. So we labeled them. So for A, if we want to find the interquartile range, the IQR, Q3 minus Q1, so we have 14 minus Q1 is 11, so that's 3. And let's look for B. IQR, we have 20 for Q3 and 17, also have 3. So you can see that these two data sets have the same variability. So even though they have different numbers, whatever these numbers may mean, they do have the same variability. Now let's look at data tables. A data table will look something like this. So here we are comparing the pounds per square inch, the PSI, of the bite force of a grizzly and a lion. So that's what we're doing here. Okay, so now you can use X's or just check marks. And remember, when you do a 4 check marks or tally marks and a line across, that's 5. So if you notice something right here, you're seeing nothing for the grizzly. You're seeing 3 lions have a bite force of 550 pounds, 5 have a bite force of 600, and so forth. So this may be misleading because you're not seeing anything for the grizzly and you're wondering what's going on with the grizzly's bite force, but a grizzly has actually a much greater bite force than a lion. So if we brought up the grizzlies, this will be the grizzly and the lion, you'll see there's nothing here when they get higher. And normally a grizzly's bite force usually falls within that category. So that's what a data table looks like. You just can put tally marks or X's. So let's use one with the length of hammerheads and great whites. So let's say that scientists were in the field and they did a study of 10 animals. They did 10 hammerheads and 10 great whites. So this is the length. So let's bring this up so you can see. There's nothing for 20, so I can just bring that down. So this was the lengths of 10 of each animal that they may have captured and measured. So with the hammerheads, you see we have a 12 feet. This is all in feet. There's one that was 12 feet, one was 13 feet, 5 were 14 feet, none were 15, and 3 were 16. And for the great whites, you have the numbers here. So when we have a data sheet like this, we want to find the MAD. If you remember what MAD stands for, the MAD was the mean absolute deviation that we talked about in the last video. So what we want to find with the MAD, we first want to get the mean of each animal. We want to find the mean length, the average length of each animal that they caught and measured. Once we find the mean, we want to find the distance that each one is away from the mean. That's how we get the MAD. So I'll do the hammerhead one, and then I'll have you do the great white one. Okay, so the first thing to do is find the mean. And so you put the numbers in order. Okay, so we add this up. We have 10 tens at least, right? So that's 100. And then we have 10, 20, 30. So 143. We have 143 is the total. And of course we're going to divide it by the amount we have is 10, and that will give us our mean. So we know the mean is 14.3. So now we want to find how far each number is away from the mean. We add all that up, divide by a 10 again, and we'll get our MAD. Okay, so if we look at 12, 12 is 2.3 away. That's 12. Then we have 13, which is 1.3 away from the mean. 14 is 0.3 away. We have 5 of them. 0.3, 0.3, 0.3, 0.3, 0.3. And then we have 16 from 14, so that's from 14.3, so that's 1.7. So make sure you have 10 numbers now. 1, 2, 3, 4, 5, 6, 7, 8, 9. We're missing one. Oh, there's another 16. Another 1.7. So that's 10 numbers. So now we have our this right here is the distance that each length is away from the mean. Let me bring that up. So now we have this part. And to get the MAD, we add all this up and divide it by 10, and you'll get the MAD. So let's do that. We add all that up and divide by 10, we'll get 1.02. 1.02 is the MAD. So 1.02 is a low number. That means that the length of the hammerhead sharks are very close to each other as far as the 10 that the scientists grabbed and surveyed and measured the length. So if this was, let's say, a 5 or higher, then you say the variability is getting wider. So in this case, the hammerheads have a low variability. Now, for you to do and hand in is to find the MAD of the great white. Right, and there was no 20, so I'll just bring it down here. Find the mean absolute deviation for the great whites. Okay, great job.